In this video, I will show you how to do a correlation and regression analysis within Excel, and therefore I will use the KLM fictional dataset, which should be available to all of you. And so here you can see within the dataset we have 4 different worksheets, and the one we are working with is the data scale distance absence. Within this worksheet, you see that there are 4 different columns. So the first one shows the employee number. So that's how you can identify basically which employee has which salary scale then. This is what you can see in the second column. Then you can see in the third column the number of absenteeism days. Here, important to know that it is the absenteeism days for 2 years. So the sum of the last 2 years. And then you can see in the fourth column the commute distance in kilometers. So here, for example, the first employee is in salary scale 3, has 38 absenteeism days and has to commute only 1 kilometer to the KLM office. So now we want to know, our question is basically if the commute distance, so how many kilometers an employee lives away from the office, how far, how this affects the amount of absenteeism days. So imagine the hypothesis is, okay, as more they have to commute, the employees, as more absenteeism days the employee has. So this we want to test by doing a correlation and regression analysis. The salary scale at the moment is not important for this example because you will do a correlation and regression analysis for that later. So now the correlation for the absenteeism days and the commute distance. So how do I do that? If you click on data, you have now here, because you have added the tool pack, the data analysis. So then you choose correlation. Okay. Now I would recommend to just delete all this to make sure that, because you just want to make sure that you have the right data for the correlation. So now we set number of absenteeism days and commute distance, the correlation between those 2 variables. So you select that, and then because you want all the data in those columns, you can click Command Shift arrow down. Okay, very important in this case is that you also have the first row here, the title, the number of absenteeism days and commute distance, because you want to have those labels afterwards in your result table as well. So then just make sure this one is there, and then you have to click here on labels in first row. Furthermore, it's important that you have grouped by columns, because if not, Excel will choose other data, which would be then the wrong analysis. So first the data, choosing, then columns, labels in first row, and then you want to have a new worksheet with the results. And so then I call it correlation. That's fine. Just correlation. You can also call it correlation and then absence and commute, because later on you will do correlation for other 2 variables, and then you have a good overview. So then press OK. And there you can see now your correlation results, your table. And now you can see, because I copied also the first row and pressed the button labels show in first row, you have now here the labels. And the correlation between number of absent days and commute distance, you can see here, is 0.0 7, 9, and so on. And as we have learned, correlations below 0.3 are low or no correlations. So based on our correlation analysis, there is no relationship between how many kilometers an employee lives away and how many days he or she is absent. But the problem here is that compared to SPSS, we don't have a p-value. So we don't know if this test we just run is actually significant. So that's why now in the next step, we do a regression analysis. Okay, now we are coming to the regression analysis. So now you can see 5 worksheets because we have the correlation, absence, and commute results down there as well. But we are going back to the data scale distance absence worksheet. So how do I run now a regression analysis? Same as the correlation, I click on data and then data analysis. And instead of correlation, I choose regression analysis. Press OK, and then the window looks a little bit different, but again I delete the input Y and X range just to make sure that we have selected the right data. So now, why do we have X and Y? So as you maybe remember, there is an independent and dependent variable. So we distinguish those 2 variables. And compared to correlation, we have to choose now for the regression, okay, what is the dependent and what is the independent variable? So the independent variable is the X and the dependent variable is the Y. So the X is in this case the commute distance. And why is that the independent variable? Imagine an employee is more days sick. So instead of 10, now 20. That doesn't mean, so that would be then X. From that, the commute distance can't be affected through the days of absenteeism, because just because an employee is more sick, they're not changing houses and live further away. So that's why the commute distance, so how far employees live away, that can affect the absenteeism days. That's what our hypothesis says. What we discussed earlier. So I put commute distance in the X range as the independent variable. Again, I press the commute distance and then I press Command, Shift, and arrow down. The same I do for the dependent variable, in this case, number of absent days. Again, Command, Shift, arrow down. Okay, then I selected here the labels again because I want again that in the result table there's written down amount of absenteeism days and commute distance, and not only variable Y and variable X. Then I open up a new working sheet. I called it regression absence commute, and then I press OK. And there you have the output of your regression analysis. So now you have a lot of numbers. So what are the numbers which are important for your report, for your results section of your report? That is the R-square, the significance F, and the coefficient, also called B. What does those 3 numbers marked in yellow mean? So first, the R-square, 0.006 means that 0.06%, so less than 1% of the number of absent days can be explained through the commute distance. Then the p-value, significance f, 5.10 and so on, and then e minus 46. If you remember the p-value, if it's below 0.05, it is significant. So in this case, the e minus 46 means that it's 46 behind the comma. So it is actually then below 0.05. So it is significant. We have here a significant correlation, but we know that the correlation is below 0.3, and therefore it is considered as a low correlation or actually no correlation. So it is significant that there's no correlation between the commute distance and the variable of the number of absent days. Then the third one, the coefficient b. It is 0.135, which means that if the commute distance increases by 1 kilometer, the number of absence increases by 0.13. So we see there's no correlation, that it's significant that there's no correlation, but that there, if the commute distance increases by 1 kilometer, that the number of absence is also increasing by 0.13.